Welcome everybody. Today in geometry we'll be talking about logic, and this is more of an introduction, so then that way you can get an idea as to what you're getting into when it comes to writing proof in geometry. So this is basically kind of like a small little stepping stone. So today we will talk about statements and also truth tables and how they actually work with each other. So to begin with, here in logic, a statement is represented by a variable. So anytime that I give you a variable, like say a, b, x, or y, it is also going to be represented by a statement, like a sentence. Kind of like in algebra, how you have x is equal to 3 or y is equal to 2. So they can be replaced in this case by some sort of sentence that I give you. So for example, in this situation, I'm going to say that the letter A is going to represent the sentence, I am a little girl. Whereas B is going to represent the sentence, tomorrow will be windy. So I have to actually tell you what those statements are actually saying first. Now, the next thing is we can combine these statements to create something called a compound statement. And the compound statement, what you're going to do is you're going to be using the following symbols over here. You can see like this upside down V, you can see this V right here, and you can see the squiggly line. Each one of those three are what is known as compounds, and they represent something in English and also in logic. So the upside down V means and. The V right here, shape right here, that means or. And this squiggly line, which is called negation, is for the word not, or it is not true. So here, to give you an example of a compound statement, let's go back to what we were saying earlier, that A and B are going to be the following sentences. If I give you the compounded statement A and B, then that means if I were to write the whole thing out, it will say, I am a little girl and tomorrow will be windy. So note how you can actually kind of match each part of the equation with something then. So we have A and B. So here you can see A right there for I am a little girl. So that's A. Then you have the word and. So that's going to be the upside down V right there. And the statement B right there. So that's going to be tomorrow will be windy. Okay, so pretty straightforward for the most part. The next one, you have B or A. So you can say tomorrow will be windy or I am a little girl. So that entire sentence will then represent that compound statement. For the negation of B, the statement in this case will say tomorrow will not be windy. So it's the opposite or the negation of the statement then. Since the statement itself says tomorrow will be windy, the negation is tomorrow will not be windy. But another way to write it so that it actually matches up with the negation and then the statement is the following inside the parentheses over here. It is not true that, and then we have the statement itself, tomorrow will be windy. So negation of B could be either one of these. I prefer to write it in this thing right here in the parentheses because you can technically see the negation and then the statement itself, which is actually really, really nice, and it could be helpful. And here is an example of kind of like Y right here, okay? So the next part, it says that we have B and negation of A. So I'm going to go ahead and write that out for you as to what it says. So B, first of all, says that tomorrow will be windy. So I'm going to go ahead and write that first. Tomorrow will be windy. And because that's the notation for it, now you can write, as I said, I am not a little girl, or it is not true that I am a little girl. Either one of those should be okay. So I'm going to write the one that I was saying earlier. It is not true that I am a little girl. Okay? So you can, again, just match it each one for each one. So this guy right here, tomorrow will be windy. That is going to be your B. Then we have the and statement. And this portion right here, it is not true that that's going to be negation of this part right here, which is going to be the statement of A. Okay. And the final example of this one would be right here where you have a big parentheses in between two statements with a negation on the outside. So this is kind of like order of operation. So the way you would write this right here is, it is not true that, and for the parentheses that you have, you can use quotation marks. So it is not true that in quotation, I am a little girl, and tomorrow will be windy. So then that way I know it's going to be the negation of the entire statement on the inside. Okay. Okay, now let's move on to something called truth table that we can use with these statements right here. So the truth table, the way it works is that it tells you the condition that a compounded statement is either true or false according to the original statements if they are true or false. So in short, it's basically saying, hey, let's say that you have the original statements. They can either be true or false. And what I want to do is I want to know the compounded statement that I'm making, is that going to be true or false according to if the original statements are going to be true or false. So here, let me go ahead and write it out so you guys can see how this actually works out. And let me go ahead and erase this guy right here, but I don't think I can, so maybe I can do that example first, okay? So, oh, there it goes. Magically it disappeared. Okay, so first off, let's think about how this works. In the following truth table, you'll see that I have A and B because I have two statements, A and B. Now, each one of those statements could either be true or false. So to me, that sounds like there are 4 total scenarios here. It could be the case where both statements are true. So I'm going to go ahead and put that into the first truth table. True or true. It could be the case where the first statement is false and the second one is true, or vice versa. So I'm going to go ahead and fill those in. So A could be true, B could be false, or it could be A is false and B could be true. And then finally, the last case would be if both of them are going to be false. So F and F. Okay. Now, once again, to help you see this a little bit better, what I'm going to do is I'm going to go ahead and write down A or B. So the statement itself says, I am a little girl. Okay. Or tomorrow will be windy. Okay, so again, what I'd like to do is look at my 2 original statements and if they're true or false, and use that to help me conclude if this compound statement that I'm making is going to be true or false accordingly. So here, let's look at the first case. If I am a little girl is true, and tomorrow will be windy is true, then the statement of I am a little girl or tomorrow will be windy is definitely going to be true. So I'm going to go ahead and put T right there. Now, in the case of where one of the statement is true, here, I am a little girl, but tomorrow will not be windy, right? The statement, I am a little girl or tomorrow will be windy is also going to be true because the word or indicates that it could be one statement is true or the other statement is true. So long as at least one is true, then the whole statement is going to be true. Okay. So with that same reasoning, then that means that for A and B, where where the first statement is false and the second statement is true, that's also going to be true. The only time that the or statement is going to be false is if both of the original statements are going to be false. I am not a little girl. It is not true that I am a little girl. And also, it is not true that tomorrow is going to be windy. So the statement of I am a little girl or tomorrow is going to be windy, it doesn't fall into either one of those categories. So that's going to be false right there. Okay. Now, for the other tables, we'll do exactly the same thing. We're going to put TT, TF, we have FT, and then finally we have FF, just to fill in all of the blanks, just like before. So in the first case, let's look at it again. TT right here. If A is true and B is true, then A and B is going to be true. This time, my composite statement or compound statement is using the word and. So let me go ahead and fill that in right there so you can kind of, we can justify this together. So that's going to be this scenario over here, erasing this guy over here. Okay. Now, if both of the original statements is true, then I am a little girl and tomorrow will be windy. Yeah, that sounds right. That's definitely going to be true. Now, here is where it's a little bit different. I am a little girl. That's true. Tomorrow will be windy. That's false. I am a little girl and tomorrow will be windy. Well, that has to be false because the word and indicates that both of these statements have to be true in order for the and statements to be true then. So if one of them is false, then that means the whole thing is going to be false. Okay, Unlike the or, where as so long as you have one of them is true, then it's okay. This one says if you have one or more, if you have one or more false, then that means the whole thing is going to be false. Okay. So next one, that has to be false too, using the same idea. And the last one, if they're both false, yeah, definitely the whole thing is going to be false. Okay, last part. Now, if I just have the statement of A, right, because this is just a negation I just want to look at, since there's only one statement, we only have two scenarios. It's either going to be true or it's going to be false, okay? So in the first case right here, I am a little girl. That is supposed to be true. Now let's look at the statement, I am not a little girl. In comparison to the original statement, that's going to be false because you're either one or the other. So then that means that this is going to be false. Whereas if it is false to begin with, that I am not a little girl, then that means that the statement, if I am a little girl is false, then that means that it is not true that I am a little girl has to be true. So it's just the opposite. Okay, so the negation part is actually pretty easy. So let's take all of these guys right here and create a truth table for something that's a little bit more complex so you can see how all of this works. So here we go. I want to create a truth table for A and negation of B using the top three right here that I just created as kind of like a theorem to help me build this. So first off, what I'm going to do is I'm going to go ahead and build 4 rows because we have 2 statements. Again, it's either true, 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 false, false, true, or false, false. So let's just go ahead and set it up as we just have been doing so far. So here's A, here's B. We have TT, TF, we have FT, and then finally FF. Okay, so those are my 4 scenarios. Now, what I want to do from here is to build that statement that I have in there. And notice that the one part that I need to solve for, if you're thinking about this kind of like an order of operation, is I need to solve for what is the negation of B, because that's what I'm going to use to solve for all of this. So here, my next column, I'm going to go ahead and build that. I'm going to go ahead and solve for what is the negation of B, because what I want to do is I want to use this negation of B to then combine it with A and negation of B to get what I want. Okay, so I'm just basically building the statements with this truth table that I have here. Okay, so let's see how this works out. So if I want to build the negation of B, I need to look at the column for B and solve for it accordingly. If you look at my truth table for negation, the way it works is that it's supposed to be the opposite. So if it's true, then it's false. And if it's false, then it's true. So that's pretty easy then. So that means over here, I'm going to have false for the first one, true for the second one, false for the first one, and true for the second one, because I'm just, again, building off the negation of the second column. Now, the last part, the whole thing that I'm going to use, okay? I'm going to focus on A, that's over here. I'm going to focus on negation of B, that's over here. And what I want to do is look at those 2 columns and then use it to build A and negation of B. Well, that means I need to look at the negation, right, as to how it works. Sorry, not the negation. I need to look at the statement with and for the truth table and see how it works and apply it over here. And says, hey, I need to take the statement, and at any time, if the statement, there is a false statement in there, then the whole thing is going to be false. So let's go ahead and take a look at it together. A says is true. A is true. Negation of B is false. So therefore, the and statement between the 2 has to be false because one of them, at least one of them, is false. In the case of where A is true and negation of B is true, then according to my truth table here, that's going to be true. If they're both false, that's going to be the bottom part right here, then that means it's going to be false. And lastly, if one is false and the other one is true, well, then the whole thing is going to be false. So there it is. That's going to be my truth table of that statement A and negation of B, according to if A and B are going to be true or false to begin with. Okay. All right. And the last one, this one, I might want you to try it on your own. Here, this is a little bit trickier. We have 3 statements. So what that means is I need to look at those 3 statements and all of the possible scenarios of when is it true and when is it false. So here, maybe I can write up the following then. And that's going to decide how many rows I actually have then. So here's one scenario, maybe for the statement of A, statement of B, statement of C, that all three are going to be true, right? So that means all three true. Then what if I have, like, say, two that are true and one that's false? So scenarios over there would be maybe the following then. We have TTF, we have TFT, and then we have FTT. So all three of these guys right here falls into this category. And then this one's the one where we have three that are true. Similarly, I can have one that's true and two that are false. So that means maybe something like this then. FFT, and then we have FTF, and then we have FFT. Oh, wrong one. It's TFF. Sorry about that one. Make a small little mistake. Okay, so that's that one. And all of these will be one true and two false. And finally, for the last one, we will have 0 that are going to be true. So that's going to be just plain old FFF. So you can see how this thing gets a little bit more complex if you have more statements. In this case, I have 8 statements because I have, I have 8 rows to consider because I have 3 statements. So, that's a nice question. Well, how do you determine how many of these rows of truth tables do you have according to how many statements you actually have? Okay, but nonetheless, those are going to be my rows right there. And then now you're going to have to build the truth table according to that then. Okay, so I'll go ahead and start it up, and then maybe you can go ahead and finish it then. It looks like I need to solve for the negation of A for one part. Then the next part, I need to solve for B or C in the other part. And from those 2 columns, that will now allow me to combine together to solve for A and, in parentheses, B or C. So that's how your truth table is going to look like. I'm going to leave that to you to try to solve for. So yeah, leave a comment if you have any questions, and I will see you next time then, okay?